All right, everybody out there in stats world, this is Coach Low coming to you with 9.2. We're going to talk about direction, form, and strength of your bivariate data represented in scatter plots. So here we go. When you talk about association and two variables have an association, basically they have something in common, okay? If specific values of one variable tend to occur in common with specific values in the other variables. So we are definitely looking for a connection between these numbers. So first thing we're talking about is direction. Anytime you have data, if you were to put all the points up here and you see your data and it makes a general trend uphill, okay, going up to the right, that is definitely going to be positive. Positive trend. If you see your data going downhill in some kind of trend, that's definitely going to be negative. And if your data is just uh, spread out all over the graph, and you really, let's say you just can't even draw a line to indicate any kind of trend, that's definitely no connection at all. Okay, so you can go ahead and say that, hey, over here, this is going to be a positive correlation, and we'll get more to what that means in a second. Positive correlation because you're going uphill, negative correlation just if you can draw the lines. And if you can draw the lines, you would basically say there's going to be no correlation. Okay. All right. So moving on to the forms, we're going to be spending a lot of time with the linear bunch right off the bat. So of course that means you're going to be able to draw a straight line representing your data. But what you're going to see in the future is that there are definitely trends that you could not express with a straight line. It just wouldn't work. So there are definitely quadratic and other kind of situations out there. Definitely, we're all going to lump them in the non-linear bunch. Okay, but again, we're going to be over here talking about the linears for now. Okay, all right, let's scroll on to the next screen. All right, here we go. We talked about direction. You got positive, negative, and then basically nothing. And now let's talk about the strength. If your data is very loosely scattered, you would consider that to be a weak correlation. As they get closer together, you're going to have a more moderate correlation. And then if your points are definitely clumped together, and look at this, they're sort of almost representing a line, that's going to be strong. And then if there basically is making a line, all right, that's definitely going to be very strong. Okay, so that's how we look at the strength of your correlation. Okay, so again, scattered out is weak, and as it approaches a line, the look of a line, it becomes very strong. So what is correlation? Technically, a correlation is a numerical measure of the strength and direction of a linear association between two variables. So it's going to be a number. Okay. Let's see here, properties of correlations. So correlation is always represented by the letter R. You're going to see that a lot, definitely on calculators. R always falls within -1 to 1, so it's definitely this interval. It's in that spectrum. And I'm going to go ahead and draw this out over here best I can. All right, so from -1 to +1 lies R. Okay, so R can be anywhere in here. Now, if it's at 0, come on, write a 0 in here. Got a little lag going on here. Nice. So if you're 0, basically that's weak, weak, weak. Okay, basically no correlation whatsoever. And then as you sort of approach the ends, as you move out towards the ends, it becomes stronger and stronger. Okay. So can I squeeze that in there? Definitely. So you're going to get stronger in your correlation as you move out, as you get closer to 1 and -1. Okay. So and I've seen it written different ways. You can say, hey, right here, this is going to be moderate. And then let's say you get to 0.75, that becomes strong. -1 becomes very strong, of course. So I've seen it written different ways, but you just need to know it is a spectrum. 0 being weak, basically no correlation. And as you move out towards 1, that becomes stronger, very strong correlation. As you move towards -1, it becomes very strong negative correlation. Okay. And again, for now, we're working just with the linears, so straight lines. And interesting factoid here is R is not dependent on either variable. So if you change up the order, you should not change up the value of R. So here's some examples. So right here, you can go ahead and pretty much draw a line. So that means definitely there is a correlation. Going uphill, so it should be positive correlation. And if you look at this number 0.989, it's pretty close to 1. So this is definitely considered strong. Okay, that is a strong correlation. Other way, let's going downhill, you can draw a line. So there's definitely is a correlation. It is negative correlation. 0.97 being very strong. All right, that is almost a line. Here we go on this example. Definitely a little bit looser. You can still probably draw a line, even though this is definitely much weaker. So negative because you're going downhill, negative correlation. 0.31 is closer to the 0. So yeah, this is going to be pretty weak. Weak to moderate. Next example, going uphill again, so you should be positive. You can definitely draw a line. And when I draw these lines, there's technically a word for this that won't come up just yet, but this is technically your line of best fit. I'm going to go ahead and throw that at you. So if you can draw a line of best fit, that means you definitely have a correlation. You just then you got to start analyzing it. So uphill, so positive correlation, 0.82, pretty strong. This one, and listen, if you start having multiple ideas of how you can draw a line, okay, that's a pretty weak line there. But definitely that means you are weak to having no correlation. So for this one, 0.54, it's actually a better number than that, okay, but 0.54, phew, since the number I'd go moderate, but it looks very weak to me, okay. In fact, I'm going to go moderate weak because they look fairly scattered. And then down here, and notice this one, they're saying negative, which means there should be a negative line. But you definitely have problems drawing a line to represent this data. And if you notice number 0.04, you are very close. So I would almost say no correlation on here because I would have trouble correlation drawing the line in the first place. So talk to teacher. They may have a certain frame for what's weak, what becomes moderate, when it becomes strong, when it becomes very strong. They may have something specific they want to work with. And a lot of times what I'll do is I'll use 2 words if I think it's sort of close to both of them, you know, hedge my bets. And on the calculator, you can calculate the correlation coefficient, which of course is going to be the R. Okay, using a TI-84, you can follow the directions. They're going to say make sure your diagnostic is on. Okay, so if you hit second and then 0 and scroll, turn this thing on, then enter twice. Interesting. Enter the explanatory response variables in L1 and L2. So this means you're going back to stats and then edit. I got some other frames coming up in a second that might help with this. Stats, then edit, and that's how you get to your list, and you can plug in your numbers in list 1, list 2. Then you're going to go to stat, then you're going to go to calculate. And interestingly enough, I remember talking to Coach Pritchard about this last year. She's got 8 on here, but I'll be honest with you, you can use option number 4 as well. You can use either one of these, okay? Both of them are going to do linear regression. One of them does like, it's got it in a different look. Hang on one second. Let me just see what it says. One's got AX plus B, one's got A plus BX. So number 4 looks like, you can check this on your calculator. It's going to look like this, AX plus B. So both of them are linear regression. Both of them can work. You just need to know that when we think about linear equations, we're always thinking y is equal to mx plus b, right? So whatever the number that is in front of the x is, this is your slope. This is your rate. So don't forget that this is going to be your y-intercept. So just know that if you're using option number 8, a plus bx, notice the form here. So b in this case is going to be your slope. A is going to be your y-intercept. Okay, and they're going to write it backwards. And I forget the reasoning why. I think it's something to do in the stats further down the line, but they'll just do that. And now if you go up to option number 4, of course, in this format, A is going to be your slope because it's in front of your x, and then B is going to be y-intercept. So just know what you're working with here, okay? All right, and over here, I tried to throw in some extra screens to help you out. You are to calculate the correlation coefficient for the average driving distance and driving accuracy. We talked about the LPG ladies here yesterday. And so what I did is I went ahead and, of course, went to stats. And then I went to edit. You're going to see your list. And again, it shouldn't matter which one you put in here, but I started with driving distance, first column, list 1, driving accuracy, list 2. And so once you get the information in there, you're going to go edit calc. And again, these are your two options, and I put them on both sides so you can see this. Option number 4, linear regression, AX plus B, is going to give you this answer right here. Okay, so notice A is going to be negative 0.005. So if you were to write out this equation, A is in front of the X, so you're going to go negative 0.00. I'm just going to round that up to 6. Then comes X plus, and then is your y-intercept, 2.16. That's what your equation. This would be the equation of that line of best fit. Okay, and then over here, if you're going with the other option, once you put your list in here, let's say you go down to option number 8, you would get this screen. So notice how it's written. So just be careful here, okay? Because B here is in front of the X. It's just written backwards. So I'll just write the way they got it. It would be 2.16 plus, so that's going to be minus 0.006 X. So it's just going to write a little differently. So just be aware. So what can you conclude about these? You know what? I not need to check on one thing. All right, so I did want to go check on something. You know, I was going through the the slide for turning your diagnostic on. I realized the calculator that I used on the screen, I hadn't done that. So when I did my number crunching right here, it did give me R. Okay, so if you actually turn the diagnostic on your calculator, you should see two more things after these. You should see R squared, and you should see R. You don't necessarily need R squared now because that goes with other types of lines of regression other than linear. That's your nonlinears. What we want is the R. So on this one, the other thing you'd want to write is what is the R at the bottom, and this one would be a negative 0.905, so I'm going to round that up to a 1. Okay, this is huge as well. This is technically your correlation coefficient. Okay, and again, if you did it over here, you should get the same thing. So these two, you want to look at both. That's your line of best fit. This is your correlation coefficient. So when they say or ask you what can you conclude, since you say yours is a negative 0.91, you would say definitely there is a very strong negative correlation. Okay, between, going back to your context, driving distance and driving accuracy. Okay. All right, got to hurry right here, a couple seconds. So on this one, I just use influential points or any points that throws anything off. And only got a couple seconds, but if you take this point out, everything changes. You can tell with your lines.